So next up, we have a couple of sessions on software-defined storage. So we got a panel, a set of key panelists, industry panelists, and I'll hand it over to Mark Lewis, who's going to be our moderator. Mark was the former CTO at EMC.
Good afternoon. So we're here to talk about software-defined storage. So maybe raise of hands. How many of you think you have a good handle on what software-defined storage even is?
Oh my God! Can't see hands
Don't raise your hands all at once. So
Yeah, really,
so
I
that's going to be. We have a couple panels this afternoon. I think our focus is going to be trying to determine both what we think it is and a little bit about what we think the core value proposition is. So we'll all spend time there, and then there's a second panel that's going to delve in a little bit more. So what I'm going to do for each of the panelists to start out is just ask you guys two things, and I'll start with a background. Give a little background of yourself, and then provide to the audience your definition of the starting point for what you think software-defined storage either is or should be in terms of definitional construct. So I was a little bit introduced. I'm Mark Lewis. I've been about 30 years in the storage industry. So I worked on I'll date myself, I worked on the first 1 gigabyte hard drive that cost $200,000. So I was calculating last night, we made $180,000 per gigabyte when I first built that disk drive. We now make 2 cents per gigabyte in profit. So you can see the change in that industry. I've done a number of things. I've been CTO, as I said, at EMC. I recently left about a year and a half ago, and I'm doing a startup now called Formation Data Systems, which we're not talking about, but is a lot more fun for me once in my life doing that. So what I did to start with this was to check what everybody else probably did is I looked on Wikipedia, because I said, well, I don't really know what software-defined storage is, so I do what everybody else did, and I said, well, let's look on Wikipedia, and what was interesting about it is even the Wikipedia said we don't really know what it is. We said it's termed right now as a marketing theme for promoting storage technologies. So I thought that was amusing.
I'll buy it.
You buy it?
We're done as a panel.
So that's what we have this esteemed panel here, because we've got to get I think we got to get the fundamentals into this first. So with that, maybe we'll start with Scott, and just introduce yourself and try to give us an idea of what you think we should be talking about here today.
All right, I'm Scott McClellan. Background-wise, I was at HP for 27 years, which that's a long time. I feel like I should keel over or something when I say that because of, exhaustion or something. And I've been at Red Hat for 1 year. At HP, I was the CTO of high-performance computing, of the business-critical servers, the group that does Itanium, HPUX, PA RISC, True64, Unix, etc. And nonstop. And then I was the CTO of a group in HP that did custom hardware for cloud service providers, which puts you at an interesting perspective on the topic because they're at the bleeding edge of new software deployment strategies. And then I was CTO of the cloud group, building an Amazon Web Services competitor at HP. And then I came to Red Hat, and I'm responsible for the big data strategy. And we're building a big data strategy on top of our Red Hat storage business unit at Red Hat, which is pretty new, which is fundamentally creating a software-defined storage stack on top of the Gluster file system, okay? So what do I think software-defined storage is? I think it's a marketing buzzword for, never mind. Instead of what it is, so with an OS background, I would argue that infrastructure and software, or storage has always been somewhat software-defined. So one of the things I was going to make as a point is I don't think it's a new trend. I think it's an old trend that's gathered momentum to increasingly to deliver the software or storage and infrastructure in general, but storage specifically, to decouple it from the hardware procurement process that, and to disintermediate the choice of the hardware that's providing the storage from the software stack that's delivering most of the value. And in a sense, the whole NAS industry is software-defined storage delivering a NFS, which is a ubiquitous client, gives you a way to get at storage through software. And it just turns out that the existing NFS vendors package that up as a hardware appliance, but it didn't have to be packaged up as a hardware appliance. And I think where we're going nowadays is you're increasingly seeing stuff like what we're doing with a software stack that delivers a lot of the value. We have a software solution that has NFS, Samba, a native file access client, plus object storage client, plus custom storage protocols like Hadoop, all in one software stack that will run on anybody's commodity hardware. So the other point I would make is I think what's important is that the industry trend is caught on because it's allowing you to get the value without using expensive proprietary hardware. It's more linked to the volume economics that's enabled by using low-cost commodity hardware. So,
Sage?
All right, my name is Sage Lyle. Just a bit of background, I came out of, I guess, high school. I created something called WebRing that you may or may not have heard of. That was a million years ago. After college, I co-founded a company called DreamHost, which is a successful web hosting company. And then in grad school, became involved with petascale storage and the Ceph distributed file system. And then after finishing my dissertation, decided to continue working on the storage system with the aim of creating a truly open source distributed storage system that gave you the sort of feature set and robustness that you expect from enterprise players, but without having to be tied to a single vendor or an expensive hardware appliance. So since then, I've co-founded this company called Inktank, which is dedicated to delivering Ceph to the enterprise, creating a production-ready system that enterprises can deploy in the real world. So I think what is software-defined storage? Beyond a good term to mention to VCs when you're trying to pump up your valuation while looking for funding, I think software-defined storage sort of has two sides to it. One is that it's really abstracting the underlying storage resources into a generic set of APIs and different storage interfaces that you consume, whether it's block storage or object storage or file-based storage. And so you stop worrying about individual storage components from the consumption of that storage, but you can deploy new devices to expand your overall storage pool and not have to worry about the details there. So there's this sort of abstraction that's taking place. But on the other side of it, it's also really an economic question. It's recognizing the fact that most of the value of your storage system is in the software, not in the hardware. And if you have a truly software-defined infrastructure, then what hardware you choose doesn't matter as much. You can really build something on top of commodity hardware and not be worried about buying expensive appliances from a small number of vendors.
Thanks. And I'm Bruce Moxon. I'm the CTO, Systems and Solutions at STech. STech is a company that's been developing solid-state storage devices for many, many years, so SSD drives and PCI cards. And I'm involved in basically bringing those into software-defined storage solutions that we can take to market as SSD accelerated or all SSD storage appliances. And I'm glad it got always to me without the obvious joke here, right? Which is what's software-defined storage? Well, I'll take the page from the definition of pornography. I can't tell you what it is, but I know it when I see it. So I use the same for software-defined storage. Actually, I'll tell you what I think it is. I actually think it's more than a marketing term. I actually think it's kind of a movement, and it's really a movement towards, and this has been touched upon, storage that's deployed, again, on commodity servers and in DAS configurations. Okay, we'll talk about that. And or virtualized cloud resources. And this is really in contrast with what I would call sort of big controller monolithic storage architectures. They're large, pick your vendor, even the NAS systems, but SAN and NAS systems. I think it can be either bare metal or VSA deployed, so virtual storage appliance. I think it can be standalone or converged. There's a whole new wave of storage architectures now called converged storage, where effectively you think about the application layer and the storage layer being sort of compressed into the same hardware, but in a scale-out architecture. And I think it can be open source, but it need not be. And I guess the one thing I'd add is kind of a why now, because I think your point earlier of software storage has been software for a very long time. It's just typically been very tightly bound to the hardware of whoever your vendor was that was providing it to you. There are a couple of things that are changing that. One is that the economics and the growth of data, right? And I talk to the financial services industry who look at 60% or greater year-on-year growth of storage needs, on capacity needs, and they have flat IT budgets and flat storage budgets. And there's basically just a big disconnect there. So something's got to give. And the answer of, well, just don't store your data or delete all your data tends not to work all that well. The second thing I'd say, if you look at the last 10 or 12 years, the two key IT data center trends around virtualization and now cloud and hyperscale, right? If you look at like the Facebooks and the Googles and the Amazons in their hyperscale architectures, there's been a move to scale out DAS for a long time coming, right? And the economics of that in terms of driving to much higher IOPS and much lower infrastructure costs, which those guys care a ton about, right? They're all about number of users or per dollar of infrastructure. I think all of those things are really driving, again, what I would call the movement.
Cool. So I'm pretty impressed. I actually think, there was a lot of synergy there. I think, while not totally defined, there is a bit of a movement. It's clearly, the software focus that we see, and there's clearly, let's say, a pent-up demand for getting off of certain hardware elements that are incredibly expensive and towards the commodity. And I think it will instantiate itself as such. Being so long in storage, one of the things I've noticed is that storage engineers and storage in general is different than compute and networking. And it's different in a couple of fundamental ways. One is it has state. And in such, by having state, meaning not being stateless, it has a different set of dimensions to it around guarantees of service delivery, performance, but it also has, that stateful performance of protection, DR, backup, and recovery. So it tends to be, in my view, more dimensional than networking or servers, and sometimes is why I think the industry lags a little bit. It also has some of the most conservative engineers on the planet involved with it. And you think about it, it's the people that store stuff. It's the people at the bank, right? They store the money. They tend to be more conservative. So Scott, maybe back to you. What do you think are the dimensions that are going to create, I think we'd all like to see this storage revolution, but we know there's some inhibitors and complexity and culture here. What are the things that we're going to start to see in the industry to get this sea change, to really happen that all of you think is going to be so powerful?
I'll just do an analogy. We had a really successful product at HP, which was the HP Blade server, and one thing that the second generation of the Blade server vaulted to well over $1 billion business in like less than 12 months or something, which is incredible velocity. And despite all that, one of the biggest things was to sell that, you had to go into the computer room and you had to there's all these little fiefdoms in the computer room where there's a network administrator, a storage administrator, a server administrator, a Linux administrator. And here we came in with this platform that had switches in the back, and we were kind of breaking down the fiefdom of the server and the network administrator. And so I think in large IT, there tends to be resistance to things that don't fit in the existing fiefdoms. Whether it's people defending their jobs or whatever. So with software-defined storage, it tends to be that the storage administrator role is kind of like at risk, and so there's a culture barrier to overcome. Just since you went to the barriers for adoption side of things, but I think what overcomes barriers like that is value. I mean, people will jump across a barrier when they see great value on the other side, right? And so because there's so much promise in terms of cost savings or productivity or enabling big data or something, it'll be the potential that'll pull people across the institutional resistance. Does that make sense?
It makes total sense. Sage, maybe a different question for you. You're immersed in the open source movement. Ceph has tons of traction and momentum in the industry, yet the storage has been, let's say, not the most favored place for use of open source technology to date. You see in the operating system world, we've done very well across, Apache and application layers you've got everywhere. Storage is, in the enterprise anyway, is pretty bereft of open source. So what's going to change? What do you think? I assume you think that there's change coming here. What's going to drive that change, and how does open source start really getting utilized effectively in the enterprise?
Well, let me start by saying that I think the change is inevitable. I think you've seen it in every other sector. You mentioned operating systems. You go back 20 years and you would buy a Sun box running Solaris. You'd buy an SDI box running IRIX. You'd go to each vendor and get your own flavor of Unix that was roughly equivalent, but with various portability issues. Fast forward 10 years, and you can buy any commodity platform and run the same open source operating systems. And the thing that really drove that is that the economics are unbeatable, right? Once you have multiple vendors that you can compete, play off against each other for the underlying hardware, and you have a common software platform that people are actually collaborating to develop instead of sort of competing, developing in silos, then you have a much better cost proposition, both for the buyer and for the people who are actually building it. So I think the reason why storage has been sort of one of the last bastions of proprietary vendors with proprietary platforms is just because people are very conservative with the data that they store. And it's a challenging problem. Storage is hard. People don't want to lose their data, and they can't afford to do that. That's changing now, though. People are recognizing that the core value that actually exists in these proprietary platforms, in the EMCs and the apps of the world, it's not about the hardware that they sell. It's really just commodity components that they put their faceplate on and package up in QA. It's really about the software that's running inside. And the irony of the situation is that they're telling you that they're selling you hardware, when in reality the value that they have, their crown jewels, is actually their software. But the businesses are actually based on essentially making money over the long term in the support contracts. So there's a lot of sleight of hand going on. But I think what's changing now is that you're finally having a crop of open source alternatives, and I guess non-open source alternatives as well, but new software alternatives that will run on commodity platforms that give you the same feature sets. They give you the same redundancy, reliability, where your data is replicated across multiple servers, and actually give you this sort of scale out that you didn't see before. And I think it's interesting that scale out is probably one of the drivers. Suddenly you have people who are deploying clouds where they need to store petabytes of data, and they're recognizing that these proprietary vendors actually can't even deliver that, although they all claim to scale. They're usually about scaling up and not scaling out. And it's really the open source options where there's the innovation that's making that happen. But at the same time, because people are sort of seeing all the changes in cloud infrastructure and so forth, and they're looking at these open source alternatives, they're realizing that they are actually solving the same sorts of problems that the enterprise players are solving as well. You have the emergence of systems like Ceph that give you things like NClusterFest that give you scale out on commodity hardware with enterprise features like snapshots and cloning and multiple API access and all that good stuff. And so it's really just a matter of time. I think the real challenge is going to be, staring the fear, uncertainty, and doubt in its face. These large existing vendors aren't going to go down without kicking and screaming and putting up a fight. So
no kidding.
I think there's one. I
power,
totally
yeah.
agree. There's one tiny little thing that Red Hat learned from perpetuating the change of an open source Linux in a commercially a world dominated by commercial Unix is you pick your battles. Red Hat didn't go after the mission critical database tier. They went after the web tier, the places. So the way you work around the conservatism is you go to the less conservative places first.
Yeah,
So
because the financial services industry, when Linux first came out, they said, that stuff's never getting in here.
now it's our
You gotta
strongest
be
sector.
crazy,
Exactly, yeah.
right?
Yeah.
And then, it was in the back room for some application, and it was, somebody else dropped it over here, and a few years, people looked around and said, what's all this Linux crap? Oh my God, I better get some support contracts, because my business is now running on it. And I think that's what's gonna happen with storage. And you're starting to see, the hot spots for software-defined storage are, I can tell you, are in like the tier 3, tier 4 NAS space, right? Where people are tired of paying $7, $8, $10 a gigabyte and don't need to. They're in the object storage, which is this new scale-out architecture in particular. They effectively are in big data. If you look at HDFS, it is a software-defined storage system. And I recall, I worked for one of the big storage vendors. I recall going to Yahoo one day and talking to them about their Hadoop deployment. And I came back and talked to our CEO. I said, you know, Yahoo has more storage in their Hadoop deployment than they have bought from us ever. And this was 4 years ago. If you look around, I think, you know, scale out DAS is all over the place, and people are finding ways to use that very effectively. They're using replicas. They're using you know, new error correction techniques across distributed architectures. The thing that I think is going to figure out where this goes first is really more around service levels and operational issues, right? So especially in deploying storage, you have to be concerned about your point earlier, Mark, right? How do I do backup and recovery if I do? Or am I comfortable with 3 replicas globally distributed as my never fail strategy? What tools do I have in place to do that? And are these systems compatible with that? Or do I have to build a whole new set of tools to do that? And that's the sort of how much or little work that is, I think, is really going to dictate the pace in various areas of the storage arena. And this is not to say that people are going to throw out their big EMC SIMs tomorrow, right? Those things are they're mission critical. They've got service levels and, you know, sub-second failover, and, you know, the maturation of software-defined storage has a long way to go before you start to incur on that, if ever. But the big data growth areas in terms of capacity are not there. They're in private clouds, big data, scale-out computing, and those are the areas where I think software-defined storage is going to make big inroads.
So Bruce, you know, you're big in the SSD space. It's another, you know, up-and-coming area of storage, and you know, storage is, as CIOs used to say. I had talked to a CIO once. He said, "I never really get rid of an application. I just build new ones." And you know, there's no such thing as just turning something off. And we have a bit of that happening in storage, is that every technology that everyone's ever bought is probably still in that data center somewhere. And so while people come in and say they're going to replace everything, in storage anyway, things tend to find another niche. And disk drives aren't going away, but flash will be here. You know, we're going to have tiered storage, and we have a lot of variability in cost, because you might want 3 replicas, or you might want 5 replicas, or you might want DR. How much do you think that software-defined storage has to address that idea of, you know, flexibility of use in terms of you know, different applications or different needs of data? I mean, is that something that you're seeing a big pull for, or people just buying flash saying, I'm just going to throw, you know,
From a solid state perspective?
Yeah, is it monolithic, or is it something where there's going to be this increase of need for more of what I would call a QoS kind of environment that really starts to deal with cost and quality as a metric? Yeah,
and you're seeing this. I mean, the areas where you're seeing, you know, solid state deploys in different capacities. It deploys on the server side, like Fusion IO has done, to accelerate applications or accelerate DAS applications. But it also is coming in on the storage side, and it's coming in both in kind of all solid state appliances that you're starting to see, but it's also coming in hybrids, so mixed solid state and hard drives, where the solid state is used, for example, for efficient metadata access, or for dedupe tables or things like that, or in an object storage arena can be used for the object metadata portion of the system. So I think you're seeing solid state in those areas. You're also seeing solid state in these all solid state appliances as a potential panacea, and I'd say it's still early, for the case where my existing storage vendor can't give me 1 million IOPS, period. And not only can I do that, but I can do that in 8U.
Do we need to virtualize across that, or are these people just treating everything as you know, individual? To me, the worry becomes the management complexity and the fiefdoms of, I got another
that's
box.
The thing that's going to slow or pace this to some extent, I think, is the management and the operations. But the cost is so compelling in certain areas, both on the dollars per IOPS perspective for solid state, and the dollars per gigabyte for even traditional large hard drive systems for object stores in Tier 3, Tier 4, that people are, they're finding the right areas to cleave off within their business, and they're going after those. And that's very much like the way Linux sort of grew to prominence, is people attacked it used it to attack the problems that it was good enough for. And over time, those problems became more and more of the traditional infrastructure. And I think that's what we're going to see. But I think you're exactly right. The thing that's going to gate it is how well these systems can be deployed and managed by an operations team that, nominally says it doesn't fit into my gold, silver, platinum level of service. I don't know what to do with it. I throw up my hands and I'm not going to support it. And then the engineering teams have to go back and figure out how to help them support it. So that's,
also,
I think, how it's going to
I think
go.
totally related to that, it also comes in the areas that are emerging versus mature. The mature areas have all the legacy encumbrance. All the new areas, people don't even know what questions to ask about. Do you fit in with this system or that system? And you don't have to work with this ticketing system or that operational procedure because it's a new area.
Right.
And that's why the big data stuff, I agree with you completely. The big data stuff's totally a proving ground. There aren't existing IT practices around Hadoop and all this stuff, so they're not having to conform to a lot of legacy stuff, for the most part, about administrative rules and procedures and checklists and tools they have to work with and stuff, so.
So Sage, you mentioned new applications. You talked about the focus, of that these things will roll out across certain areas where, as you say, the culture might be ready for it. Is storage finally ready to interact with applications? From the standpoint of, provisioning and management and what we really see as becoming kind of application connected?
I think so. I think there's sort of two sides of that, depending on how you interpret your question. I think there's the management of these, complex distributed systems, and obviously there's a lot to be done there. But there's also, I think more interestingly, there's also a change in the way that people are building applications that interact with storage. Traditionally, you have your storage system sitting over here, and you have your application sitting over there, and they're speaking some protocol in between. A lot of the innovation that could have happened, even keeping that model, has been hindered by the fact that we have to conform to certain standards.
Crappy old protocols.
You're a proprietary vendor, and you're stuck providing NFS or SIFs or whatever, because that's your only choice, and you don't have control of the client. Some of that's starting to change. I think that's one of the areas where open source in particular has some advantages because they can be much more agile. But even ignoring that, I think you see even proprietary platforms being built where you just expose different sets of APIs, and it's actually not that difficult to take certain classes of applications and rewrite them on top of those.
Right, the traditional vendors have put object store interfaces on top of their traditional storage. They've put HDFS versions on top of it, so they've adopted.
It's not even just that. It's not just exposing the same underlying storage via different API, but it's also the ability to reason about it in a little bit different way. So you can actually ship computation to the storage.
Or management protocols that allow the application to know protection performance levels that it wants from particular storage automatically.
Which is what we've had to work on as we're doing an integration of Hadoop on top of the Red Hat storage. You have to put the QoS in place so that you can still serve your NFS transactions while running your Hadoop jobs and guarantee a certain throughput and stuff like that. And that's still, a lot of that's work in progress, but that's dependent on isolation and QoS and that sort of thing. But Hadoop's a formalization of a very popular paradigm for developing applications where you want to move the data to the compute. And, we've talked about it in the industry for a long time, but here's one that caught on, And so, it's really forcing the hand on compute and data fiefdoms breaking down and coming together. So, and the movement is very powerful around the Hadoop ecosystem is very strong and growing very quick and all of that. So
I think that the two proof points that I look to are the success of Hadoop and people actually leveraging this entirely new way of thinking about structuring computation and data, and the success of Amazon S3, where it's a totally new storage API, and it's gone, gangbusters. And it's really just because it's, fully elastic and commodity, and it scales out, right? That's as long as you can get those two things, and people can rewrite their
So that was the point. You tapped on elasticity. I think that, Amazon has put elasticity into people's heads from an application design perspective. And that's great when I can fire up EC2 instances, but what do I do for my storage, right? What do I do when I need to go 10x capacity for 5 days because I've got these new data sets I want to analyze, and then I'm going to aggregate them or blow them away? How do I do that also to get elasticity and performance that matches all of my EC2 instances that I've got? Because I need the capacity and the performance. And so all of this is to come, I think, but I think it's just one more thing that's going to drive these new storage architectures.
I think you need a software-defined storage system to do that.
There you go.
There we go. The end of SCSI. No. So I want to thank the panel. I see we are now red lighted for being done. Hopefully we got the first part of this accomplished, which was to define and kind of talk about the core issues. So thank you to the panel.
For our next discussion, we've assembled together a set of pioneers who essentially are the very early adopters of SDS technologies, and they're kind of here to talk about and discuss their experiences with us. And our moderator is John Mark Walker, who is the Gluster Community Manager.